Hi guys, how you guys doing? This video is for people who already know the basics of trigonometric identities. If you don't know what these identities are, I request you to pay attention, memorize, and understand as we show them on your screen. So first, we have reciprocal identities. Sin theta equals 1 over cosecant theta, and cosecant theta equals 1 over sin theta. Cosine theta equals 1 over secant theta, and secant theta equals 1 over cosine theta. Lastly, tangent theta equals 1 over cotangent theta, and cotangent theta is equal to 1 over tangent theta. Second identity is ratio identity. Tangent theta equals sine theta all over cosine theta, and cotangent theta equals cosine theta over sine theta. Lastly, we have Pythagorean identities. First, cosine squared theta plus sine squared theta equals 1. And if you're looking for the value of cosine squared theta, you will have 1 minus sine squared theta. And if you're looking for the value of sine squared theta, you will have 1 minus cosine squared theta. Next, you will have secant squared theta minus tangent squared theta equals 1. If you're looking for the value of secant squared theta, you will have 1 plus tangent squared theta. If you are looking for the value of tangent squared theta, you will have 1 minus secant squared theta. Lastly, we have cosecant squared theta minus cotangent squared theta equals 1. And if you are looking for the value of cosecant squared theta, you will have 1 plus cotangent squared theta. And then if you're looking for the value of cotangent squared theta, you will have 1 minus cosecant squared theta. Hey there! So you're having difficulties solving and proving trigonometric identities? Well, you have come to the right channel. Me and my team created this video tutorial lesson so that students like you can understand and learn how to prove identities even if it seems to get hard. Let's get straight to the examples.
So here is the problem number 1. We have cosine squared x equals cosecant x and cosine x over tangent x plus cotangent. And for the problem number 2, we have cosecant beta over sine beta minus cotangent beta over tangent beta equals. For the problem number 3, we have sine x minus cosine x squared plus sine x plus cosine x squared. And we have our problem number 4. Tangent squared x plus tangent x and secant x equals 1 plus sine x over cosine squared x. And for our problem number 5 and our very last problem, we have sine squared x plus 4 sine x plus 3 over cosine squared x equals 3 plus sine x over 1 minus sine x for our solution.
Cosine squared x equals the value of cosecant is 1 over sine x multiplied by cosine x all over the value of tangent sine x over cosine x plus the value of cotangent cosine x over sine x. From our solution 1, we can now combine the denominator and we will have this. 1 over sine x times cosine x all over sine squared x plus cosine squared x all over cosine x and sine x. From our solution number 2, we can now simplify our numerator which is cosine x over sine x all over sine squared x plus cosine squared x all over cosine x times sine x. Next, combining the whole fraction, and remember, when we are dividing a fraction to fraction, we have to reciprocate the denominator and rewrite 1 as the value of cosine squared x plus sine squared x. And then proceeding to simple multiplication, we will have cosine squared x times sine x all over sine x, and we can cancel sine x. And there you go! You have cosine squared x equals cosine squared x.
So tangent beta and cosecant beta minus cotangent beta and sine beta over sine beta and tangent beta. So for the second is sine beta over cosine beta times 1 over sine beta minus cosine beta over sine beta times sine beta over 1 over sine beta plus tangent beta. So cancel all the sine since it has all the same value. So 1 over cosine beta minus cosine beta over 1 over sine beta and tangent beta. Fourth, we have 1 over cosine beta minus cosine beta over 1 over sine beta times sine beta over cosine beta. Fifth is 1 over cosine beta minus cosine beta over 1 over sine squared beta over cosine squared beta. For the sixth is 1 over cosine beta minus cosine beta over 1 times cosine beta over sine beta squared beta. So for the seventh, we have 1 minus cosine squared beta over cosine beta times cosine beta over sine beta squared beta. For the eighth, we have 1 minus cosine squared beta over sine squared beta. Ninth is 1 minus cosine squared beta over 1 minus cosine squared beta. 1 equals 1. So our next is sine squared x minus 2 sine x and cosine x plus cosine squared x plus sine squared x plus 2 sine x cosine x plus cosine squared. So number 2, sine x minus 2 sine x and cosine x plus cosine squared x plus sine squared x plus 2 sine x and cosine x plus cosine squared x. So you cancel the 2 sine x and the other one because it's just the same. So we have the third one. 1 plus 1 equals 2. 2 equals 2. So there you have it. Our next one is secant squared x plus sine x over cosine x times 1 over cosine x. Second, we have secant squared x plus sine x over cosine squared x. First, 1 over cosine squared x plus sine x over cosine squared x. So we have sine x plus 3 and sine x plus 1 over 1 plus sine x, 1 minus sine x. So second, we have sine x plus 3, sine x plus 1 again, over 1 plus sine x, 1 minus sine x. So you cancel sine x plus 3 over 1 minus sine x plus sine x over 1 minus sine x. There you have it, the end. Thank you for watching, guys. I hope you learned a lot today.